Assalamualaikum warahmatullahi wabarakatuh. Hello, everybody. I will present my research result for publication for ICRAMET 2020. Let me share my presentation. Okay, here. It is my presentation for International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, or ICRAMET 2020. My title is Experimental Based Identification Model of Low Fluid Flow Rate Control System. It is me, the presentation. I, uh, my name, Jalu Ahmad Warosa. Also, the team member, they are Edi Kuniawan, Hendra Adinanta, Suryadi, and Purwo Wibowo. We are from Research Center for Physics, our institution, Indonesian Institute of Science, or LIPI. My background of research, the low fluid flow rate usually used in the beverage industry, rain gauge, and fuel system. Low fluid flow rate is have a small flow rate and also usually in the small diameter of pipe. We can explain more next. We want to develop external control system so it can generate accurate flow measurement for good quality of product. We go in beverage industry for drinking product or good quality of rain gauge measurement. Also in the fuel, we can how to maintain the fuel machine so the it must be use the accurate control for the flow rate in the machine in the transportation particularly. Moreover, adaptive system to robust theory in control, it can be applied in control system for improvement for its model. We can also use the flow meter as feedback element. Also, we can use actuator such as solenoid valve and diaphragm pump. We can use it. We want to develop accurate uh, model for low fluid flow control system from the real behavior, also from the experiment result. This is our big background of research. Our objective of this work is to develop identification model of control system from real experiment plan behavior of low fluid flow rate control. It is about control system model. You can see in this picture. We use sensor, flow meter sensor, uh, especially Hall effect flow meter to measure flow rate as feedback element. And the system for actuator, we can use valve and pump. In this research, we use solenoid valve and diaphragm pump. Uh, But actuator we can compare which one is the better for control the flow rate. Let's experiment and design model. It is we use a microcontroller to generate PM to the driver. Why we use driver? Because signal uh, current signal from the microcontroller is very low, so we need driver to strengthen it to move the valve and pump. So this actuator can control the flow rate. We can use flow meter to measure this flow rate. This type of flow meter has effect. Flow meter use pulse. The output is pulse, so we can use um, the interrupt facilities in microcontroller, particularly digital input to count the result of flow meter. You can see in the system identification that we use. System identification used to identify from the real experiment data. The output from this method is transfer function. Transfer function, they are output comparing to input. The output of this patient activity is pulse and time. It is actually it is flow rate because flow is equal to number quantity of volume divided by time. The pulse from the flow meter is equal to number of uh, volume. So it is pulse and time is the flow rate for the output of the system. And for the input of the system, it is voltage, it is PWM signal, pulse width modulation. This is actually like microcontroller 5 volt equal to 255 bit and so on. So we can generate from this output to input to generate the model of control system in transfer function. So you can see in the this is the picture of an experiment. The microcontroller. We use Arduino. The included here a driver. So they are in here flow meter. This is solenoid part. It is a pump. So in this picture, we are doing experiment and take some data. Let's continue. This is data, experiment and the design method. Yeah. This is data for the pump. This is for the valve. You can see from the pump there is signal 78% of signal. You can see the data is more unstable and but more become more stable. The pattern here, the red cycle, also the same. The red cycle, the pattern in the this measuring result. But this is for 88% signal, larger signal. Contrastly, for valve, the data is not good. Here, there are no pattern. So, we decide to use the pump data because they have good and better ability to control the flow rate. The data, the step response here, we can track the data. We can use software. You can use MATLAB. They are system identification toolbook. You can use this toolbook to use system identification method. You can input the experiment data. You can then you can generate uh, the transfer function control system model. Here, the result, uh, we can make a variation of the number of pulls and zero. I see this is the accuracy, 2 and 1, 2 and 1 and 1, 1 and 0, 2 and 0, and 2 and 2. Is the best. You can see the best is with the two pulls and two zero. It is the best. You can see the accuracy. We can simulate in the MATLAB, make comparison from the model and the experiment data. The result almost close, not only in the 7-8% PWM, also the larger signal. The accuracy is 95%, also close to 90%, 87% here. We make my comparison. Let's continue to the conclusion. So, for identification model for low flow rate for below 80,000 milliliter per minute, or uh, we can cite it is for liter per minute below this, and diameter is very small for the pipe, 8 millimeter. It is my definition for low flow rate as a successfully built and presented in this presentation. They are for first time they are unstable, but uh, next they tend to be stable. You can see the data. It is for first time unstable, but tend to be stable. We can see it is need here need warming time about 70 seconds. Yes, almost 1 minute more to stable. Also from the data, diagram pumps better the ability of control than the valve. Also the solenoid valve is not recommended to control the low flow rate. Also the number of pulls and zero is the better is two respectively. You can see from the table the best combination is 2 and 2 number of pull and zero. Okay, and also the other type of valve, we said solenoid valve we can use the ball valve, butterfly valve we can use the other in the next research. If you're interested you can do it. So or closed loop algorithm we can also use in the future, um, such as proportional, integral, and derivative algorithm or PID control we can use. Maybe if you're interested in the next. So this is our presentation, our system based identification model of fluid flow rate. Thank you for your attention. Save, please save your healthy in pandemic of COVID-19. We must take care of ourselves and our family, our social. Uh, uh, Keep be happy and healthy. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.